Okay, today we're going to start by talking about the fundamental counting principle. You guys have actually already heard about this. We're just going to refresh your memories a little bit. So it says E sub 1 is an event with N sub 1 possible outcomes. And E sub 2 is an event with N sub 2 possible outcomes. All right? The number of ways that events can occur in sequence is N sub 1 times N sub 2. So multiplying the possible outcomes by the possible outcomes. So an example of this would be like number 1. In Sierra's closet, she has 12 blouses, 6 skirts, and 9 pairs of shoes. How many different outfits can she make? So the events would be blouses, skirts, and pairs of shoes. The possible outcomes would be 12, 6, and 9. So we would take the 12 possible outcomes times the 6 possible outcomes times the 9 possible outcomes. And what do we get? 648. That means she can make 648 outfits. Now, just so we're all on the same page, that doesn't mean all of those outfits look good. Okay, she might have like an orange sweater with like a green skirt, okay? We're really just talking about like how many different like patterns or how many different fits can she make. Does that make sense? Now, we could also imagine that all of these 12 blouses are neutral colors, all of these 6 skirts are neutral colors, and all of these 9 shoes go with all of these. That's what, you get what I'm picking? Okay. Whew, those words. All right, let's go to number 2. So, most non-personalized license plates in the state of Utah consist of 3 numbers followed by 3 letters. Hence the keyword non-personalized. These are just the ones that you don't pay any extra for. They just give them to you. Now, they exclude the letters I, O, and Q. Why do you think they would exclude those? Yeah, they're hard to see. They're hard to differentiate between each other and between other numbers, and it needs to be easy to read. So they want to know how many different license plates are possible. Now, sometimes things are not as easy to understand and to figure out in your head as like number 1. So what I do when I see a problem like this is I think through of like what the license plate should look like. It's going to have 3 numbers, followed by 3 letters, okay? Now, when it says 3 numbers, how many choices do they have for numbers? 10, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 options for my first number. Did they say that those... So in this problem, did they specify that you could not have any letters repeating or any numbers repeating? No. So that means for my second number, I still have 10 options. I could have 0, 0, 0 or 1, 1, 1. So for my third option, again, I could still have 10. No big deal. Okay? Now for my letters, they did specify that there were 3 letters that I couldn't use. So how many options does that leave me with? There's 23 letters. And again, can those repeat as well? Yes, so we can have 23 and 23. Now, all of these outcomes just have to be multiplied, just like we did up here. So we need 10 times 10 times 10 times 23 times 23 times 23. And what does that give me? Oh, dang. 12,167,000 license plates. And that doesn't even include the personalized ones. Okay, so you can have over 12,167,000 different license plates. Okay. Oh yeah. Make sure that you multiply because we want. Good. All right. So let's look at number 3. Number 3 says you have a stack of 5 textbooks: English, history, statistics, geology, and psychology. Okay. How many ways can you arrange them on a shelf? Ooh, I don't know. How many books do we have? 5. So we're going to have 5 books, and that means we're going to have 5 different slots to put them in. Slot 1, 2, 3, 4, and 5. Does that make sense? So how many options do you have for that first slot? 5. You can put history first, you can put English first, statistics, geology, or psychology. You have 5 options. Now, let's say I choose that I want to put statistics first because it's clearly the most important. How many options do I have? I don't know why I did that. I should put the 5 on the line. How many options would I have for my second slot? Then I only have 4 options left. So then let's say I already chose statistics. Then let's say I want history to go second because that's kind of interesting to me. Then how many options do I have for my third slot? 3. So let's say then I want to put psychology because Mr. Brooks is a great teacher. How many options do I have left for my fourth option? 2, and I'm going to put English because that's great. And then that means I only have 1 book left for my last option, and that's going to be geology because no thank you. You know what I'm saying? Okay, now we just multiply those all together. 5 times 4 times 3 times 2 times 1. And how many different ways can I arrange them? 120 ways. Now, that actually leads me to the next thing we're going to learn about, which is called factorial. This, 5 times 4 times 3 times 2 times 1, is another word for saying factorial. Factorial is when you take a number and you multiply it by the following smaller numbers all the way down to 1. So if it was 3 factorial, it'd be 3 times 2 times 1. If it was 10 factorial, it'd be 10 times 9 times 8 times 7, all the way down to times 1. Does that make sense? Now, when you see it written in, there's like a shorthand for it. There's like a shortcut for it. We would write it like this. 5 times 4 times 3 times 2 times 1 would be 5 factorial. It has an exclamation point after it. Or 10 factorial, why can't I write today or talk today, is an exclamation point after it. Are we okay with that? Now, one thing you need to note is that 0 factorial equals 1 by definition. Like, that's just the definition of it. 0 factorial is 1. Okay? I know that kind of doesn't make sense, but it just is what it is. Now, on Excel, you can actually do factorials, but just note, if you type in equals 5 exclamation point on Excel, it's not going to work. That's not how you do it. You have to type in equals FACT of whatever number you want. So here's my Excel. If I wanted to figure out what 5 factorial would be, which we already know is 120, I could just be in the cell and I would type equals FACT of 5, and we should get 120. Okay, so again, don't type in equals 5 exclamation point. It does nothing. It doesn't work. Are we all okay with that? All right. Next. The next thing we're going to talk about is called a permutation. A permutation is a specific order or arrangement of objects in a set. There are n factorial of permutations of n unique objects. All right? So on number 4, it says, to complete your holiday shopping, you need to go to the bakery, the department store, grocery store, and the toy store. If you are going to visit the stores in sequence, which means you're not going to visit a store more than once, how many different sequences exist? Okay? So how many options do you have to visit your first store? 4. So let's say you go to the bakery first. How many options do you have for your second store? 3. Then let's say you go to the department store. How many options do you have for your third store? 2. And then you go to the grocery store and you only have 1 option left, right? That means order matters, okay? Order matters here. It needs to be in a specific order. That means we just take our 4 options and we're going to take the factorial of that. So in Excel, we would type in equals FACT of 4. In our calculator, what would we type? Do you have an exclamation point in your calculator? Fascinating. Or, I mean, it's just multiplication. So 4 times 3 times 2 times 1 is what? 24. So there are 24 different sequences that you could have. Okay? Number 5 says, at a local food restaurant, the door to the kitchen is secured by a 5-button lock. labeled 1, 2, 3, 4, 5. What a weird lock that's going to look like. To open the door, the correct 3-digit code must be pushed, but each button can only be pushed once. How many different codes are possible? So we have how many buttons? 5, but how many are we going to use for this lock? 3. We can only use 3 buttons for this lock. We have a first number, we have a second number, and we have a third number. How many options do we have for that first button we could push? 5. Now, you cannot use the same number twice, so how many options do I have for the second button? 4, and how many options do I have for the third button? 3. So 5 times 4 times 3 gives me how many different codes? 60. There could be 60 different codes that you could have for that lock. Okay? Now that's kind of like a factorial, but note it didn't use all 5. Okay? So that's where it's a little different. Now that leads me to what we call the number of permutation of n unique objects in which k are selected at a time and repetition is not allowed. This example is an example of permutations where we can only choose so many. We don't have to choose all of them. So how to compute permutations in Excel. Remember, permutations means that order does matter. So in Excel, you would type in equals, P-E-R-M-U-T, permute, and then you would have 2 numbers, the number that you have followed by the number that you chose. Now, in shorthand, it looks like this. In permutation k equals n factorial over n minus k factorial. Now, other notations you may see, sometimes you'll see it written like this, where the n and k come after the p, or p of n comma k, which is just like you would have it here. So let's try this again, but this time let's use the formula. Okay, this time let's use the formula. So it's on the back side of your paper. It says 7 sprinters have advanced to the final heat at a track meet. How many ways can they finish in first, second, and third? Does order matter with this? Yes, because it's first, second, third place. Can you have anybody be in there twice? Can someone be both first and second? No, you can't. So that's how we know we need to use a permutation. So in this problem, what we're going to do is we're going to identify what our n value is and what our k value is. Now the n value is how many that you have. How many that you have is your n value. How many sprinters do we have at this meet? 7. Your k value is the number that you are choosing. So we have 3 different places, first, second, and third. My k value is going to be 3. Now to find NPK, which would be 7 permutations 3, it's going to be n factorial. What's my n factorial? 7 factorial over n minus k factorial. So I'm going to take the 7 minus 3, and what's that going to give me? 4 factorial. Okay? Now, in your Excel, you can type this in 2 different ways. You can type it in, where am I at? You can type it in like this. You can type it in as equals factorial of 7, close your parentheses, divided by factorial of 4, and that'll get you the answer. Or we know that we can now use that permutation command. So we can say equals P-E-R-M-U-T, open parenthesis, and it specifically tells you, remember, like it'll tell you what you want, number followed by the number chosen. So how many numbers did we have? 7, comma, how many did we choose? 3, close your parentheses, and we should get the same. So, dang it, keep pushing the wrong button. How many total ways could we find a first, second, and third place finisher? 210 ways. Now, given that does not take skill into account, all right, you could probably like whittle that down, being like, well, you know, Jordan's clearly faster than Mrs. Getz, so he's obviously going to be in the top 3, while Mrs. Getz is going to be the very last, and it's going to be fine. Does that make sense? That does not take any common sense into account. Let's go to number 7. Number 7 talks about distinguishable permutations, okay? Distinguishable permutations take into account when you have multiple choices that are the same. So if in objects with in sub 1 alike, in sub 2 alike, and in sub k alike, then the number of distinguishable permutation is given by this. That makes zero sense when you talk about it in math talk. But if we give you an example, it's going to be a lot more understandable. So let's look at number 7. How many distinguishable permutations can be made from the word Mississippi? Now, how many letters are in the word Mississippi? Total letters. 11. There's 11 letters. Okay? Now, we're going to look at this here. Let's start with the word M. How many, or the letter M, how many times do you see the letter M in the word Mississippi? Once. Then I have the letter I. How many times do you see the letter I in Mississippi? 4 times. What about the letter S? 4. And what about the letter P? 2. Okay? So this is different than the other permutations because we have repetition. Okay? When we were talking about arranging the books on the shelf, we didn't have 2 statistics books. All right? So those were all distinct from each other. But these, when we are dealing with distinguishable permutations, I have 4 letter I's. I have 4 letter S's. So when talking about permutations, I don't want to use the letter I more than once. Does that make sense? So what we do is we take this and we put it into this formula. Now the first thing is we want in factorial. In is the total number of letters that I have, which is what? 11. So I'm going to have 11 factorial. Divided by, now I'm going to look at all of my choices. How many different choices do I have? 4. I'm going to take each one of these choices factorial and multiply them together. So my first choice is 1 factorial times my second choice, which is 4 factorial, times my third choice, which is 4 factorial, times my fourth choice, which is 2 factorial. Then we just put that either into Excel, in our calculator. It's completely up to you to figure out how many distinguishable permutations can be made from the word Mississippi. And you should get 34,650 distinguishable permutations. If you didn't get that, make sure if you put it into your calculator, this dude is in parentheses. Because order of operations is going to want to take 11 divided by 1 permutation, then multiply. We want all of this to be multiplied in the denominator first. Okay. Now the next thing we're going to talk about is a combination. A combination is a collection or grouping of objects where order is not important. Permutations, order is important. Combinations, order is not important. So, how to compute combinations on Excel? You're going to type in equals combin, C-O-M-B-I-N, and then you're going to have the number you have, comma, the number you've chosen. Again, number you have is in, number you've chosen is K. It looks like this. In choose K, and the actual formula of it is in factorial over the quantity of in minus K factorial times K factorial. Again, you can see it written in these 2 ways, C of in over K or C of in comma K. And let's talk about some kind of problems that this might apply to. So on number 8, in South Carolina's Palmetto Cash 5 lottery, a player selects 5 different numbers from 1 to 38. Inclusive means we include 1 and 38. If the numbers selected match the player's number in any order, the player wins. So what is the total number of winning combinations? So we're going to have 38 choose 5. There are 38 options and we only have to choose 5 of them. Order does not matter. Now, you could use this formula right here, or the easier way is let's put this into Excel. That's going to be a combination, C-O-M-B-I-N, of 38, comma 5. 38, choose 5. So in Excel, we're going to have equals combination, C-O-M-B-I-N, of 38, comma 5. And how many different combinations could we have that would be winning? Very good. There are 501,942 winning combinations. Now, what's the probability of actually winning? One out of 501,942. Now, fractions are a little bit intimidating to us, so if I tell you that's the probability of winning, that really doesn't mean much to you. But if I give that to you as a decimal, 1 out of 501,942. Ooh, 1.99 e to the negative 6th, which would be about 0.000002. What's your probability of winning the lottery? You have a higher chance of getting struck by lightning twice. All right. Let's go to number 9. A restaurant is promoting a Valentine's dinner for 2 by offering the following promotion. The couple may choose 2 appetizers from 7 on the menu, 2 entrees from 6 on the menu, 4 side dishes from 13 on the menu, and 2 desserts from 5 on the menu. In how many ways could the couple choose a meal during or using these parameters? Now, this is kind of like a problem that you're going to see on Hawks, and I'm not going to lie to you, this problem confused the crap out of me because there's so much going on. So I'm going to break it down in a little easier way. So it says the couple may choose 2 appetizers from 7 on the menu. Okay? They can choose 2 entrees from 6 on the menu. They can choose 4 side dishes from 13 on the menu and 2 desserts from 5 on the menu. So how many different courses are they having in this dinner? There's 4 different courses, okay? We have appetizer, entree, sides, and desserts, all right? Let's just focus on my appetizers. How many appetizers are there in general? 7. And how many do we get to choose? Does order matter with those 2 that we choose? No. So would that be a combination or a permutation? A combination. So for the appetizers, we're going to have literally 7 choose 2. Okay, what about entrees? How many options do we have? 6, and how many can we choose? 2. So would that be combination or permutation again? So this would be 6 choose 2 combination. So what do you think sides are going to be? 4 choose 13. And what do you think desserts are going to be? Oh, yeah, sorry. 13, 4. 13 choose 4. Sorry. What about desserts? 5 choose 2. So those are just for the appetizers, entrees, sides, and desserts. How do you think we're going to get the final amount of choices for our entire 4-course meal? What do you think we're going to do with those numbers? We're going to multiply them. Now, guys, don't do this in your calculator. Way too much work for your calculator. Here's how we're going to do this in Excel. Let's go to Excel. Okay? So I'm going to come over here, and I know that we have appetizers, entrees, sides, and desserts. Okay? I'm going to zoom in so it's a little easier for you to see. Oh, no, we don't want to zoom in like that. All right, so for appetizers, we said that was 7 choose 2. So we're going to type in equals combination of 7, choose 2. So there are 21 different choices or different combinations that you could do for appetizers. Then we're going to do the same thing for entree. So we're going to do equals combination 6, choose 2. For the sides, combination 13, choose 4. Ooh, there's a lot of options for sides, dang. And for the desserts, combination 5, choose 2. Then what did we say we were going to do with all of those? Multiply. So what kind of sex is that with multiplication? There's not like a sum feature for multiplication. You literally just have to go equals, and then I'm just going to say that cell times this cell times this cell times this cell. So equals, for me, I have G1 times H1 times I1 times J1. Okay? What should we get as our answer? Wow. So that means we have the possibility of 2,252,250 different meals. Wow. Okay. Yes, sir. That's fine. Oh, the combination? Yeah, that's okay. Finally, we have, what's the difference between combinations and permutations? Combinations order does not matter. What about permutations? Order matters. Okay, so, and this is going to throw you for a loop. Let's talk about a combination lock. You guys know what I'm talking about? Combination lock? Is that a combination or a permutation? Ooh, on a combination lock, does order matter? Yes, if the combination is 38, 24, 12, that order is important. So really, it should be called a permutation lock, but it's a combination lock, which is really confusing. All right, that's all I got.